Right now, a rogue neutron star is still tearing through the Milky Way at 3 million miles per hour, and NASA has no way to stop it, slow it, or even predict where it's heading next. They've tracked it for decades. They've watched it accelerate away from everything. And what they found when they ran the numbers is the part they are afraid to say out loud. It has a name. RX J0822-4300. You won't find it anchored to any star map because it belongs to none. It was born in an explosion so massive it ripped a star apart and flung its collapsed core outward like a bullet fired from a cosmic gun. That core is a neutron star, a dead sun crushed down to the size of a city, compressed to a density so extreme that a single teaspoon of its material would weigh 1 billion tons on Earth. Hard to picture, harder to accept. Astronomers first spotted it inside Puppis A, a supernova remnant drifting roughly 7,000 light-years from here. They assumed the neutron star would be coasting slowly, the way most debris does after an explosion. They pointed the Chandra X-ray Observatory at it and started measuring. What they found rewrote their assumptions about how much force a dying star can deliver to its own corpse. But that's not even the part that worries them. Here is the first problem. 3 million miles per hour is not a drift. It is an escape velocity. Most neutron stars born in supernova blasts receive what physicists call a natal kick, an asymmetric push from the uneven collapse that sends them moving outward through space. Normal natal kicks produce velocities in the range of several 100,000 miles per hour, fast but bounded, contained. RX J0822-4300 is moving at nearly 4 times the average escape velocity for our entire galaxy. That means it is not orbiting anything. It is not gravitationally bound to anything. It is leaving permanently, and as it moves, it is functionally invisible. No visible light, no radio signature you could catch without specialized instruments in orbit, no warning at all before it passes through a stellar system. It threads through space like a ghost tearing through walls, and from the ground you would never know it was there. Right now, it is already 2 degrees off from where it started. In astronomical terms, that gap is enormous. And it is still moving. But here is what stopped the scientists cold. When they mapped the remnant of Puppis A, all the debris from the original explosion, and calculated how much energy that supernova released, the numbers did not match the neutron star's velocity. Not slightly. Significantly. The explosion that gave birth to RX J0822-4300 should not have been powerful enough to launch it this fast. The energy available, calculated from the size and shape of the debris field, falls short of what achieving 3 million miles per hour would require. Some physicists point to asymmetric neutrino emission, particles escaping unevenly during core collapse, acting like a rocket nozzle firing in one direction. Others invoke magnetic field acceleration. None of these explanations fully close the gap. And the gap matters. But that's not even the strange part. Here is the strange part. It shouldn't be possible at all. The Chandra observations, refined across multiple years of data, show something that doesn't fit any model they had going in. The neutron star's velocity has remained consistent, not decelerating the way a kicked object should as it fights the gravitational pull of surrounding matter. It is moving as if something is sustaining it, or as if it was launched by a mechanism more powerful than a supernova. This is the open loop from the beginning. This is what they found at the end of the calculation. This is what they're afraid to say out loud. Because if the energy budget of a stellar collapse, one of the most tightly constrained measurements in all of astrophysics, cannot account for this object's motion, then either our models of stellar death have a fundamental hole in them, or something happened inside that explosion that our physics cannot yet describe. The collapse itself takes milliseconds. We have never directly observed one in real time. Everything we know comes from the wreckage it leaves behind. And the wreckage is telling us the star is moving faster than the process that created it should allow. That is not a rounding error. That is a signal from something we do not understand. What does this mean for us? In terms of immediate danger, nothing. The current trajectory of RX J0822-4300 does not cross our solar system, But that kind of reassurance misses the larger point entirely. We have only located neutron stars that were visible, one spinning in a way that aimed radio beams at Earth, or close enough for X-ray satellites to catch their heat. We have no census of the rogues moving silently through the galaxy right now. No inventory, no map. Every supernova produces a neutron star, and this galaxy has seen billions of supernovae. Some of those remnants formed binary systems, but others, kicked hard at birth, are threading through the dark between the stars. Silent. Invisible, moving, and here is the question no one will answer on the record. If we found one neutron star moving faster than our physics can explain, how many more are out there that we simply haven't looked for yet? That dead city-sized star is still out there right now, still leaving, still accelerating away from everything we know. What do you think is moving through the silence between the stars, and what happens the day we finally find it aimed at something we care about?